So here's how to train an image recognition model. The first step is obtaining your training data. It is possible to get a hold of pre-annotated images, but depending on what you're doing, you may need to gather and annotate these images yourself. The amount of images per classification you're going to need can vary, but around 100 per class can generally be considered as the smallest amount you can probably get away with, depending on what you're doing. RoboFlow is a tool that you can use to annotate and manage your dataset. There are, of course, others you can use, but this is the one I use. Something to keep in mind about manually annotating a set is that it is an extremely tedious task. There are automated tools that you can use to make this process easier, but garbage in, garbage out, feeding AI output into AI training data is kind of like how printing a copy of a copy results in a gradually worse image. So we're going to create a new project, name it Bananas, select object detection, select files. This is nowhere near large enough a data set to even remotely be useful. This is just for the purpose of an example. Select label manually. Select bounding box. So we got all the images annotated. Going to select add 3 images to dataset. This is where you decide the split of training, validation, and testing. Training is what sets the parameters. Validation is how it checks the parameters that have been set. And testing is an evaluation of how it does with a set of data that it was not exposed to during training. Generally, you're going to want 60 to 80% on training, 10 to 20% on validation, and 10 to 20% on testing. Now we create a new version, name it Bananas 1. Do pre-processing. Generally, you're going to want to make sure that your images are the same size. Now you can download the dataset. And this code is a snippet that will allow you to download. So here's how to actually run the dataset through the model. Pip install Ultralytics to install the package for the YOLO models, then import all of this. I have the model set to YOLO v8. You can set the path to your dataset where it says path to dataset here. The epochs is the number of times the dataset gets run through the model. Too few epochs and your model won't actually learn any patterns. Too many epochs and your model is going to be overfitted and focused on noise in the data. If you don't want your dataset to use a square resolution, set rect to true. You're going to need a lot more than just one epoch. This is just for the sake of example. MAP50 is a measure of how often there is a minimum of 50% overlap between the box the model places and the actual bounding box in the data. MAP 50 to 95 is like the MAP 50, except it averages the score across several thresholds. Keep in mind that this process can take a while to run. A dataset of around 200 images at 75 epochs took around 4 hours to complete. Here are two examples of programs for displaying the results from the models. This first one works on a saved video file. Place the path to the file containing the model weights where it says path to weights. Set the path to the video file where it says path to video. Conf is the confidence. If the result of an estimation for a classification is below this threshold, it will not be displayed. This next one works with screen capture. As you can see, it is a little more complicated than the last one. You're going to need to import OpenCV and a few other things. Put the path to the model weights where it says path to weights, just like with the previous one. This last bit at the end just sets it so that the program is terminated when the Q button is pressed. So here's an example of that first program in action, and here is an example of that second screen capture based program in action.